right.
What do you want to know about this thing?
All right, Stan. When someone passes by and says, whoa, that looks like South America, Africa. Whoa, it is. That's a world. What are all these cracks? What is this? What is this map? How was it made?
Cracks of the world.
Right. Cracks of the world.
What's the date on that, by the way?
2007. John Mark Stouty.
Right. So
Stan
this is
Keith.
the thing that I worked on for a week over a set of slapped together drafting tables. I mean, the table we worked on was about from there to there, and it was about 30 feet long.
Whoa.
And they had
up with Monty at his place in Colorado. We're talking, and I thought, we really do need to capture and keep and make sure that the world knows that there is this alternative ways of thinking about deposits and thinking about geology and creativity. And we created Cracks of the Earth together. I remember working on that over the Super Bowl weekend. So everyone's watching the Super Bowl, and Stan and I were butts in the air, elbows on maps, doing layer after layer because we had access to all the BHP mag data and other gravity data as part of my working at BHP. And we were trying to put together the structures to target where there could be the world's giant deposits, as I was leading the part of the exploration and the innovative new opportunities group of BHP at the time.
all their geophysical maps, and we were just sitting there.
It's like 10 feet by 30 feet long.
Yeah, you know that there's a... they were selling them at the time, and they wound up giving them to us for some reason, but what the hell was it? So, no, so we had fault maps, geologic maps. That was one data set. But to see down, those things only just see the stuff at the surface. So we used mag and gravity.
Okay.
And
bunch of chutes spliced together.
Yeah. And also we used another biggie, which is even more informative than the geologic maps, was the topographic maps of both of the continents and the bathymetry of the oceans.
Whoa.
So we got a really nice data set of these great big maps of bathymetry and continental topography.
Wow.
And each one of those maps, they were panels, and each panel was about like from there.
Holy smokes. Here. Wow.
And we had like 7 or 8 of them.
Wow. That is awesome.
Ultimately went around the planet. And then we had John Mark got the BHP geophysicists into it because they've always been wanted an excuse to splice all their data sets together anyway.
Nice.
So it took them about 6 months to do that.
Whoa.
And then when we got them all done, then John Mark, we went up and had this 1-week party.
Oh my gosh.
3 of us, me, Ron, Luthi, and John Mark. And that was so fun. Oh, that was great. And we banged this out. But the test plot
was in there.
Was right in there.
Yeah.
And then I had another client of mine, Gary Heinemeyer, who was here in Tucson. We need to interview him.
Yep.
He's
on the list.
down here. He says, all right, that's really cool. So what I'm going to do is have you do I want you to do Western South America and Western North America. So I did. And then John Mark, by then we went over to Noble Energy, and she said,
Susan Cunningham.
yeah, she says, okay, you need to take this sort of planet. And so we had the data set there, but it wasn't nearly as good as, and then John Mark saw it, and he says, now I got a project. And so
that is so cool.
This ultimately came out of that, but there's still work to do here. For example, this thing that's coming across here looks like it connects over to here.
Oh, no kidding. Yeah.
Well, it does.
Yeah,
it's just
does.
that this is one of the few places in Siberia where we didn't have good mag gravity. So we just couldn't do anything.
Right.
We just had to be honest about it.
That's interesting. Same with Africa, or is Africa that?
Yeah, there's all kinds of gaps that can be filled in. So this is still in progress. This is just a progress report.
This is the most detailed progress report on the planet.
Report.
The most detailed one on the planet. This is a funky
promotional thing.
What is this funky ass wedge? Sorry to cut you off on that, but it's striking. What is?
Well, it's a microplate bounded by the Carnegie on the south, which has got the Galapagos hotspot on right, just right about here.
Yep.
Okay, so that's the Carnegie Ridge. That's the Galapagos hotspot right about there, and that's where all my favorite iguanas take rafts to. The reason those cracks are there is that they're reflecting the northward translation of South America jamming itself into Central America. And this is, a lot of the strain relief goes out into this triangular area.
It's a crazy wedge of complexity in the whole.
Yeah, and it is more complex. That's real texture. And whereas this is just kind of dead stuff, north and south. And in fact, if you just take that, you can wrap it in, you can go on shore with it. And you can wrap it up into this thing, which goes out into here, and then you can wrap this thing over into this thing. And that whole thing is one big giant sigmoid. Watch me doing that.
Whoa!
Push left, yeah.
Bang!
And that's a deformed rhombochasm, a gigantic continent scale rhombochasm. It's reflecting those plate motions.
Wow. Tension's happening where at the bend.
Right, and look at all the oil that leaks into that. Yeah, the tension would be...
No, that's compression.
That's shear, and
yep.
That's sort of pseudo-shear, and this guy is tension. That is the tension. Right?
Bang, right there. Tension.
Look at all the effing oil in that. All those brown-orange things are the oil guys. That's the Venezuela oil province. It's Maracaibo. All these big things over. That's Trinidad.
Wow. Damn, that is so cool. So can you essentially find just smaller versions of that other places, and you're going to find some other more
fractal. I mean, it
more
goes
traps
on at all scales. Yeah. Well, San Andreas is another example of it.
Right. That big bend is right around here.
Right.
Holy shit. The other striking features are obviously the Deccan traps and the
East Ridge. That's
I mean, what a crazy little feature that we have on the Earth right there. Perfectly straight freaking lines practically on the planet.
The rip as India's, again, you have a strain boundary that's that northward translation of India.
You had a massive low energy freaking trap thing there. Why did everything just crunch over there? On a line too. I mean, this stuff just is.
The Indo-Ganges thrust zone.
This thing's just jamming. I mean, it's ready to go. It's railroading into the Himalayas.
Yeah, that's right.
I mean, how do you get the tallest mountains in the world? Well, we got to talk about the ocean floor for a minute.
Well, you got a doubled up continent thing going on.
Yeah, you see these railroad tracks.
Simple isostasy.
And it ran out of tracks. It just simply ran out of tracks. It would have cruised around the whole world.
Yeah, well, exactly. It jammed up the whole plate track framework.
And we got it age dated.
But just before it hit, and that was in the Eocene, everything on the planet was at fast speed.
Really?
Yeah, that's what flat subduction is. High
speed subduction stuff.
Yeah.
Whoa.
So when India hit, it turned off all of the flat subduction we had going on under North America because it jammed everything up. And so then since you lost the velocities, then all the subduction zones collapsed.
And slowed down, and things started getting steeper.
Exactly, and started breaking up and blah, blah, blah. Wow. And the arcs, which had been pushed onto the continents, started to migrate back towards the trenches.
Stepping back in the trenches.
Yeah. So by 15 MA, you have the Caneo Volcanics over where you were living.
Yep. And then
Santa Monica. It's not.
What the heck and how the heck did the tectonic equator get built?
The Managua Fault here is going to be a big-ass place to look for oil, and it is. But the biggest one of all is this goddamn tectonic equator thing. And then over there.
What? When did that happen? You guys are going, whoa.
That is another gigantic Earth scale wrench, left wrench. So this whole thing is in tension here. And you have the East African Rift System there. So this whole thing is in tension. From there to there.
Wow. Whoa.
And you're looking at hydrocarbon seepage just coming all the way up through there and then all the way through here. This thing's that's an active geosystem, by the way.
That's Guar?
As a matter of fact, the arrow is on Guar.
Yep. So this is an active geosystem in North America. I mean, it's got it.
No, I don't know about that, but well, it's an interesting question. We'll just say that. Yeah, just like that.
We'll talk to him. Let's talk about it. All right, so the plate tectonic, what I know is everything above it is about left lateral strike slip, and everything below it is about right lateral.
Nominally about right lateral, yeah.
Yeah. And so it hangs around the southern.
So that's a huge strain boundary between left shear on the top half of the planet and right shear on the bottom half of the planet. And it's not symmetrical. The planet in general is favoring left shear, 2/3 of it.
Right.
But if you look at it from the poles, that's where you can really see what's going on. So you can see that basically these fault systems like this guy here, it literally goes all the way around the planet. And then it comes back over here.
Yeah, mid-oceanic ridges, and then it goes across continents.
You can just sort of see all of these latitude parallel faults. You know, and then they get offset by other stuff. But I mean, basically, the first order fault system is you've got a torque axis here, is spinning this way.
Boom.
And so you're creating cracks that are longitude parallel, roughly.